I think we are live. Okay, let me check. Hi everyone, welcome back to Geeks for Geeks practice. So we are here for the discussion of the contest. Quickly give me a thumbs up in the comments and like the video as well so that I can know that my voice is clearly audible to all of you and the screen is also visible. We'll be starting in a couple of minutes, right? We'll be starting in a couple of minutes. Let's just wait for others to join. Till then, you can quickly tell me in the chat like how many questions you were able to solve for this particular contest. You can tell me the number. Okay, so the voice is perfectly fine, right? All of you can tell me how many questions you were able to solve, guys. Quickly tell me in the chat. Right, so the first the question overall problem set was really good. If you look at the problems, the overall problem set was really good. Like if you see this problem, minimum number of steps, so it was a kind of easy problem, I would say. And like maximum level sum in a binary tree, it was also a good problem. Like you had to find the maximum sum of a particular level, right? And then the third problem was a DP problem, and it was like wall coloring too, right? Hi Shreya, how many problems you were able to solve? Hi everyone. All of you can give a thumbs up in the chat, to the video, like the video as well, guys. And quickly tell me, am I clearly audible to all of you? Okay, so we'll be starting in just 1 or 2 minutes. I think the notification has gone a little bit late. Okay. So the problem set was pretty interesting today, especially the very first question. Like I liked it a lot. Minimum number of steps required. It was a good question, I would say. Right. So we'll be starting off in a minute only. I'm just waiting for others to join. Is there any issue with my voice? Let me just check. All right. So how many problems you were able to solve? Quickly tell me in the chat, guys. Quickly tell me in the chat. How many problems were you able to solve? How many did you solve? Quickly tell me, and then we'll quickly tell me how many problems you were able to solve. Then we'll start with the discussion of the problems, right? So the very first problem that we'll be discussing is minimum. So the first problem that was there was minimum. Where is Soham? I don't know. The first problem that we'll be discussing is minimum steps required, right? So in this problem we will be given a string, right? So in this problem what they will do is, they will give you a string, right? They will give you a string, let's say str. So let's say what they give you is bba, right? So in this problem, the first problem, that is minimum number of steps, right? So in this problem, minimum number of steps, what they will give you is, they will give you a string, let's say b a a b b. So they will give you a string that will consist of only the characters a and b, right? The string that will be given to you, it will consist of only two characters a and b, and what you need to do is, you need to find the minimum number of steps that are required to remove the consecutive characters, right? You need to find the minimum number of steps that are required to make the string empty by removing consecutive characters. So in this case, if you see for this example, so what I can do is, in the first step, right, in step 1, right, in step 1 what I can do is, I can remove this particular contiguous segment of a's, right? And the moment I remove this contiguous segment of a's, so what happens is, this contiguous segment of a's will get removed, and the new string after the first step will be bb, right? Because this portion is removed, so this and this part comes together. And then you can see that in the step 2, what I can do is, I can remove the total b's, right? So the string would become empty. Is this part clear to everyone? is this is it clear to everyone? Is it clear to everyone? Clear with this part, guys? Clear with the problem statement? Right. Let's try and take some examples. Let's try and take some other examples. So let us say that what I have is, let's say I have A, let's say I have B, let's say I have again triple A's, and then I have B and A, right? If I have this kind of an example, right? So if I have this kind of an example, so you have to notice that if I remove this segment of B and this segment of B, right? So if I take two steps, to remove the segment of B, right? If I take two steps to remove the segment of B, then what I can see is that in after this two steps, what will happen? A, right, triple A's and then double A's, right? So all the A's will come together, right? If I remove this B and this B, like this consecutive B's in one step, these consecutive B's in the second step, in that case it becomes A, and then in that case I will take one more step, so total three steps I'll be able to do this thing, right? Is it clear to everyone, right? So now you can, like, can you relate it to something? Yes, you can relate it to something, right? Can I say that what is the like, if you do this thing, if you do it this way, so basically what you can observe is how many contiguous segment of A's and B's are there, right? You can keep the count. You can have a variable count underscore A, in which what you can do is you can count the number of consecutive A's, right? So like, can I say that this is one of the segments, this is one of the segments where consecutive A's are present. This is also the second segment where the consecutive A's are present. This is also one of the segments where consecutive A's are present, right? So there are total how many segments? Three segments where the consecutive A's are present, right? So in the count underscore A, what I've kept is I've kept the number of consecutive segments of A. Now what is the different consecutive segments of B? If I do it in count of B, so I can say that this is one such segment and this is the second segment, so total number of segments is B. Now which segment will you try to remove? Will you, like, can I say that if you look at the question, right guys, if you look at the question says that you have to find the minimum number of steps required. So can I say that I should remove which segment? I should if I remove the segments of A, right, if I do this, right, if I remove the segments of A, then in that case I'll take three steps and then all the B's will come together, right? If I remove the consecutive segments of A, if I remove this segment, then the B's will come together, right? And I'll take one more step, so total four steps will be there, right? Total four steps will be there in that case. But the second thing that I can think of is, like, if I remove the segments of B, right, if I remove the segments of B, then I'll take two steps, and then what will happen? All the A's will come together, right? All the A's will come together, and then I can take one more step, so that the total number of steps will be three, right? So which segment will you remove first? Can I say that you will remove the minimum of the count of A and the count of B plus 1, right? You will do what? The overall answer will be what? Which segment will you remove? Your task is to remove the segment, like you will remove that particular segments, like you will remove that particular alphabet first of all, which will do what? Which will help you to get the minimum number of steps, right? So if you remove B, if you remove this B and this B, then total two steps will be taken, then all the A's will get together, so for that one more step, so total number of steps will be three. But if you went and removed three, if you removed A first of all, then you removed then all the B's come together, then you remove B at one step, so total steps will be four. So which is more optimal? Can I say that the final answer for this case, I can understand that I'll remove the minimum, right? I'll remove the minimum, right? I'll remove the minimum of count underscore A, comma, count underscore B plus 1, right? Is this clear to everyone? Clear with this part? Everyone can write a clear in the chat, guys. All of you can write clear in the chat. Everyone is clear with this part? All of you are clear with this part, guys? Is it clear to everyone? Is it clear to everyone? Is it clear to everyone, guys? Right, so that's how you will be doing it. So basically what I can say is, like, how do you count the segments, right? How will you count the contiguous segments? So is it clear to everyone? I hope that it is clear. You can write a clear in the chat, guys, for that. So if you see this part, if you see that you have some A's, right, then you have some B's, then you have these A's, right? Suppose this is the case, right? So if you have suppose B's as well, so in that case the count of A's and the count of B's will be the same. In that case, like, if the count of A's and the B's, the contiguous segments are same, in that case the minimum will be 2 only. But suppose that this case is there, right? Suppose this is the case, so in that case what will you do? First of all, your I will be here, right? So what I can think of is, I'll start my I, right? Let's start writing the code a little bit here. So what I'm thinking is I'll have this thing, I'll have what? I'll have I'll have int first of all I starting from 0. My I is gonna start from 0, and I'll have the count underscore A to count the contiguous number of segments of A, and I'll have the count of underscore B, right? That will tell me about the contiguous segments of B, right? Once I have the contiguous segments of A and B, then I'll start my iteration until I reach the end. Okay, I'll start my iteration until I reach the end. And what am I going to do, right? What am I going to do? So I'll say that, okay, I'll say that I am here. If I'm here, that's perfectly fine. If I'm here, so the same like I'll say that, let's say that what I do is I'll mark a j here, right? I can maybe mark a j here. I can say that only initially this is my starting position, and I can say that I move here, right? So I can say that this is one such segment, right? And the moment I move forward, the moment I move here, so I'll say that okay, the moment I move here, so the segment has changed, right? The segment has changed. So I can say that in this part I'll say the count of 1. So in that case, what I can basically say is I'll say that int j is equal to I initially. This will help me to keep a track of the segment. So I'll say that what if it happens that the current string character, if the current string character I is equal to a, if it's an a character, then what I will do is I'll count all the a's together, right? I'll check for that particular segment. So I'll say that count underscore a plus plus, right? I'll say that count underscore a plus plus, right? I'll count the segments of a, right, simply. And what I'll say is if str of I is equal to a, right? If str of I is, let's say, equal to a, or you can say j, in that case I don't need this variable, right? Maybe I can skip this. So I'll say that if str of I is equal to a, if it's equal to a, then what I do is I keep on moving my I, right? I keep on moving my I one by one, right? And then what I can say is I can say that in that case I'll be, can I say that in that case I'll be moving to my j will eventually move to this character, right? Eventually what will happen, my j will start pointing to this particular character, right? My basically I will start pointing to this particular character, and in that case I can simply say that if my I is pointing to this particular character, then I will do an I minus minus, right? Because I'm also like because every time I'll be doing, like, I'll be here, right? So if I want to start again, so I'll be here, so that the next iteration whenever I do I plus plus, so I can move to this point. Okay, so that's why I'll say that I'll do an I plus plus, because I have moved one step more forward, right? So that's why what I will do here is I'll do here an I minus minus, right? Okay, and similarly I'll check that if it happens that the count, or like if it happens that the current character string of I is equal to b, right? In that case what will you do? If the current character is equal to b, in that case what you will do is count underscore b plus plus, right? That is what you are going to do. And what you will say is that while string of I, the current character, is, let's say, equal to b, right? In that case I'll do an I plus plus, right? And why like after this part, why am I doing an I minus minus? Because every time I'll be doing an I plus plus, so why am I doing I minus minus, right? Oh, basically what I can say is maybe I can instead of this I can run a while like this for loop, int I starts from 0, I is lesser than n, and then I plus plus, right? So every time my I will keep on moving after the segments. So before that I need to do an I minus minus, right? Because every time what is happening, suppose my I is standing, right? Suppose I have counted one of the segments, and my I is standing here. So if my I is standing here, right, if my at the end of the after this my I is standing here, so one of the segments has been counted, right? So in this case I can say that what will you do, right? I can say that what will you do, right? So one second, let me check the audio. Okay, my audio is perfect, right? So what I will do here is I'll have my I here, right? And since I'm having my I here, so in this case I'll say that okay, if I'm having my I here, so in that case I should do I minus minus, because next time I'll doing I plus plus, right? So I should do I minus minus, so I is pointing here, and the next time in the loop whenever I do I plus plus, right? Whenever in the loop I do an I plus plus, in that case I'll move to this character b, right? I'll move to this character b, okay, and I'll check for this segment. Clear with this part? Everyone is clear with this part, right? That is what I am thinking. And basically what I can say is, what will you return? You will return nothing but what? Minimum of the count of a segment, minimum of count underscore a, right? Comma count underscore b plus 1, because whichever segment is minimum, whichever number of consecutive segments are minimum out of a and b, that you will be considering, and plus 1 for the other character segment, right? Basically if you have a and b, like this kind of a case, so you can observe that what you will do is your count underscore a is nothing but 2, and the count underscore b is what? Count of b's is 1. Consecutive a's are having two different segments, and b is having just one segment. So if you remove this b, then all the a's come together, then you can remove all the a's, right? So that's why what you will do is minimum of these two, so that is 1 plus 1 step more for the other character, right? So minimum of the segment of one character, and then the plus 1 for other character, right? That is what you will do. Let us try and compile this to see if it works here, right? So it's kind of a CP problem. It is saying that n was not declared. Okay, so I should say that I should run until str.size, right? I should run until str.size. Let us try and compile this to see if it works. Thanks, Shreya. Others, what about others? Others are also clear with the problem. Seems to work on the samples, I think. All right, so let us try and submit this to see if it is working or not. So I think it will get accepted. It was able to pass all the test cases, right? So this problem has been successfully solved. Is it clear to everyone? Everyone is clear with this problem or not? You can write a yes in the chat, or everyone is clear with this problem. Can we move to the next problem after this? If everyone is clear, you basically count the number of consecutive segments of A, the number of consecutive segments of B, and first of all you will try to remove that particular segment which is minimum, right? So that all the other characters, all the segments come together, and after that, like, you will try to remove the minimum segment, right? Whichever is having the minimum number of different segments, whichever character out of A and B is having the minimum number of segments, and then other characters will come together, and one more step for that. So that's how you can minimize it, right? So let's try and move to the next problem now. Okay, so okay, +1 is perfect. Now let's try and move. My audio is coming out to be correctly, right? My audio is perfect, right? Guys, quickly tell me. I'll just check that once more so that there is no issue further. 1 second. Okay, let us move to the next problem now. So moving on to the next problem now, what does this problem say? Right, this problem, if I'll quickly walk you through this problem. So what does this problem say about this thing? So this problem says that maximum level sum in a binary tree. Okay, so let me try and copy this test case. First of all, let me try to copy this test case. You have understood the, like, you were satisfied with the first solution, right? Now let's move to the second. So in the second part, what I will be doing is I'll have 4, and then I'll be given a binary tree. Okay, so if I'll be given this, let's say this is pointing to -5, right? This part is pointing to -5. Then what I have is I have -1, I have 3, and here I have -2, and here I have 6. Okay, this part is there. So now I am having this part, right? I'm having these things. What I need to do is, now what is the question asking? The question is saying that what you have to do is you will be given a binary tree with positive and negative nodes, and you have to find the sum of a level, maximum sum of a level in a binary tree, right? So if you see for this level, the sum will be what? The sum will be 4, right? For this level the sum will be 4. For this level, what will be the sum? The sum will be the sum of these nodes. So what will be the sum? The sum will be nothing but what? The sum will be -3. And for this level, if you see for this level, right, so the sum for this level will be what? The sum for this level will be nothing but what, like 6, right? Because -1 plus 3 will be 2, then 2 minus 2 will be 0, and 0 plus 6 will be 6, right? So that is clear to everyone. Hi Mahesh, right? So that will be the case. In this case, the sum will come out to be 6, right? So what is the maximum sum? I can say that out of these 3, I'll always keep a track of the maximum, right? So for every level I'll have the sum. So I'll say that maximum is equal to nothing but maximum of mx comma sum, right? So what is the maximum sum that I can see? The maximum sum that I can see is nothing but 6, right? Okay, so that is how I'll be doing it. So basically I can use the BFS traversal. Agree with me on this part or not? I can find the sum of all the levels one by one. I can find the sum of all the levels, right? Once I find the sum of all the, like, once I find the sum of a particular level, I can compare it with the maximum sum that I've seen up till now, and then I can basically print it, right? Yes or no, guys? Right, clear with this part? Everyone is clear with this part or not? Everyone is clear with this part? You can write clear in the chat if you are clear with the logic part. Everyone is clear with the logic part? Everyone is clear with the logic part or not? Yes, all of you are clear with the logic. That is what you have to do. Basically you can run a BFS traversal and do this problem. So basically, if you see, right, everyone is clear with the BFS traversal or not? Right, you can run a BFS traversal, level order traversal. You can have a level order traversal, and you can find the sum one by one, right? You can write yes in the chat, everyone, if you are clear with it. Everyone is clear with it? All of you are clear with this part? Okay, everyone is clear with it, right? So what I will be doing is I'll say that now I need to process all the nodes at the same time, right? So I'll have a size as well for me. What I'll have is I'll have this queue with me, right? I'll have this queue, right? Queue data structure with me. I'll initially insert 4 into it, right? In the queue, basically I'll initially insert 4 into it, and then what is the size of the queue, right? So the size of the queue tells me that okay, at this particular level how many nodes are there, right? Agree with me on this part or not? Right, basically what is there is the size tells me the number of nodes. The size of the current queue tells me the number of nodes at a particular level, right? At a particular level, at a particular level, right? So that will be the case. So in this case, if the size is 1, so that means there is just one node. So what I'll do is I'll do a size minus minus, right? And I'll take out the node 4. If I take out the node 4 inside this loop, right? So I'm doing size minus minus. So the next time size will be 0. So while loop will not run. Okay. So 4 will be taken out, and then after that 2 and minus 5 will be inserted, right? And in this case, the sum of this particular level will come out to be 4. And is it greater than the maximum? Yes. So currently I'll say that the maximum sum that I found up till now is 4. Then what will happen? 2 and minus 5 are inserted, right? So after that, what happens? My sum changes to this thing, right? My sum, my size changes to 0, right? My size now is 0 because I have processed the node 1. There was just one node here, so that's why I've traversed the level. Then at the next level, the size, now I'll say that size is equal to q dot size. So whatever is the number of nodes in the queue, so I'll say that there are 2 nodes, right? So I'll process both of them, and I'll say that if I find, I'll do a while minus while, like I'll do a while size minus minus again, and I'll iterate through these nodes, right? I'll iterate through these nodes, and I'll find the sum. So the sum first of all will be 2, then it will be like 2, and like initially I'll mark the sum as 0, right? For every level traversal I'll mark the sum as 0, and then I'll say that sum is equal to what? Sum is equal to 2 and minus 5, it will be minus 3. So is it greater than the maximum? Is minus 3 greater than 4? No, it's not, right? So up till this level, for the first level and the second level, up till the second level, the maximum sum is what? The 4, right? Agree with me on this part or not? The maximum sum up till the level is nothing but 4. So that is why what I will say is that I'll not update the sum, right? And I can say that in the BFS traversal, while I was doing the BFS traversal, so 2 and minus 5 will get eliminated, right? First of all, 2 and minus 5 are there, so 2 will get eliminated, and 2's children will come, right? 2 will get added in the sum, and then this will happen, right? So size will change to 1, and then the sum will be 2 here, right? For this level, then what will happen? Minus 5. So you add minus 5 to the sum, so 2 plus minus 5 is equal to nothing but minus 3. Sum becomes minus 3, and you'll add the children of minus 5. So minus 5 sum like children is minus 2 and 6, right? So that is what you will do. Then what you will do is you will say that, okay, now what is the size of the queue? Now what is the size of the queue, right? So now the size of the queue is nothing but, the size is what? The size is nothing but 4. If my size comes out to be 4, so in that case what is happening? If the size comes out to be 4, so that is nothing but minus 1 plus 3 minus 2 and plus 6. So that comes out to be 1 by 1. You will be processing the sum, so the sum comes out to be 6. And is it greater than the maximum? Yes. So that's why I'll update it, and I'll simply, once all the, like, now what will happen, all these nodes will come out, right? All this will be popped out, and the queue will become empty. The moment queue becomes empty, so I can return the maximum sum. Clear with this part, everyone? Everyone is clear with the logic part, right? Everyone is clear? Okay, now I'll tell you how you can implement it. Like so what you will be doing is you will be having a queue here, right? So okay, one second. So what you will be doing here is you will be having this thing, you'll be having the queue, let's say queue of what? A node star root. You will be making a queue for yourself, and what you will be having is you will be having the maximum sum. So initially you will say that if you want to find something, right, if you want to find something maximum, so can I say that you can initialize your maximum to int min? Agree with me on this part or not? You can write agree in the chat, guys. If you want to find something that is maximum, if we want to find something that is maximum, so for that what we do is we mark it as minimum, right? Initially we think that it is minimum, right? So what we will do is we will say that what if the root is not existing, right? If it happens that root, let's say the root is equal to null. If the root is equal to null, in that case I should return the mx, like that is the minimum value. Let's say if the root is null, then possibly I should return a 0, I think, right? Okay, if the root is null, then there is no maximum sum, right? So maybe I can return a 0, let's say. And then what I can do is I can say that q dot push the root value. I'll push the root value inside it, and then I'll say that while q dot size, right, q dot size is greater than 0, right? Until unless the q dot size is greater than 0, I'll keep on moving, and I'll say that int sz is equal to nothing but q dot size. So that will help me to find the this is what this is telling me about the number of nodes in the current level, right? Is it clear to everyone? The current size is telling me about the number of nodes at the current level. So what I'll say is I need to mark my sum initially as 0 for this level, and then what I will do is I will say, because the nodes can be negative, so that is why I need to take the max mx is equal to int min, right? And after that what I'll say is I'll do a while size minus minus, right? Agree with me on this part, everyone? So what I'll do is I'll have the size minus minus, and I'll process the first node. So I'll say that what node star current node will be what? Current node will be nothing but q dot front. I'll take out the front node and I'll pop it out, okay? And then I'll add it to my sum. So sum plus is equal to nothing but what? Sum plus is equal to nothing but current's value, current node's data, right? Current node data, right? And then once I've done with this part, so what will I do? I'll check if it happens that the current left child is existing, right? If the current left child is not equal to null, if the current child left child is not equal to null, in that case, what will you do? What will you do? You will say that you need to push it into the queue. You need to, if the left child is not null, so you will push the left child into the queue, right? And then you will also say that if the right child, if the current right child, okay, if the right child is not equal to null, in that case, what you'll do? You will say that q dot push what current right child, okay, that is what you will do. And once you are done with this part, right, so every time you are processed with a level, right, so this sum will calculate, this sum variable will contain what? This sum variable will contain the sum of nodes of current level, right? It will contain the sum of the nodes of the current level. So I'll say that maximum is equal to nothing but maximum sum is equal to nothing but maximum of mx comma sum that I've calculated for this particular level. So level by level it will keep on processing, and in the end possibly what I can think is I can return the mx, the maximum sum that I've calculated, right? Is it clear to everyone? Everyone is clear with this part? Let us try and compile this and see if it works on the samples. Okay, it is saying that node star root. Okay, I should say that node star q. Sorry, I should not say this thing. I should say it like this. Now it should work. Basically, I declared I did not name it as q, right? It is giving us as the answer is 6. Let us try and submit it. It should get accepted, I think. Okay, it is queuing. Currently, it is compiling. Let us see that if it gets accepted. I think it should get accepted. It is evaluating. So it was able to pass all the test cases, right? So is this problem clear to everyone? Everyone is clear? We were able to do this problem. All the, like, it was able to pass. The problem was successfully solved, right? So basically what you do is you, like, this is nothing but the current level, right? This is nothing but the current level, right? Current level, because you store all the nodes at the current level and then you try to take the sum of it, right, in a while loop. This while loop will not increase your complexity because it was going to run for the current number of nodes at the current level it was going to run, right? So you first of all store it one by one, right, and then you check with the maximum for this level, right? That is what you will do. Is it clear to everyone? Everyone is clear with this question? Okay, right. The next question that we have is wall coloring 2, right? So what does this question say, right? What does this problem say? So how many of you were able to do this problem, right? Did you, like, were you able to solve the first two problems? You can tell me quickly, guys. Every one of you were able to solve the first two problems or not? Well, like, you can hit the like button. We have solved the first two, like we have solved the two problems, right? I told you this problem, minimum steps required. If you look at this minimum steps required, so as I told you, what you will be doing is you will be counting the segments of ones and A's and B's, and whichever is the minimum segment, you will first of all remove that, right? When like minimum contiguous segments of A's or B's, out of that whichever is the minimum, you will do that, and then you'll add +1 to it, right? That is what you will do. Thanks a lot of enough, right? And then if you see, look at the next example. So that is nothing but maximum level sum of a binary tree. So in this approach, what you can understand is I did nothing. I did a BFS traversal. What I did was for all the current nodes at the current level, I took out the sum. I always compared it with the maximum, and in the end I returned the maximum sum. Okay, that is what I did. Now the third question is a good one. It's a DP problem. So how many of you were able to do this question? Now if I talk about this question, right, just let me check if the audio is fine. Okay, the audio is coming out to be fine, right? So now all of you can hit the like button, guys, right? So let's discuss the next problem, right? So in one of the interview series, I know that a wall coloring problem was asked, but this is an extension, right? Now, like, what does this problem say, right? So it says that there are n walls in a geek NAND, right? So there are n walls. Total number of walls are n. So let's try and collect the data. The problem name is wall coloring 2, right? It's a DP problem and it's easy, right? Wall coloring 2 problem. Now what does this problem say, right? This problem says that you will have n walls, right? So initially what you will have is you will have n number of walls, right? You will have n walls initially, and in this part, if you have n walls in the geek land, so the king of the geek land has ordered Alexa to color all the walls on the occasion of New Year. So all the walls will be colored, right? All the n walls will be colored, right? All the n walls will be colored. That is also perfectly fine. All the n walls are going to be colored. Now after they are going to be colored, so how are they going to be colored? So Alexa can color each wall with one of the key colors, right? So basically what is happening, like there are total k different colors, right? There are total k different colors. There are total k different colors, right? So Alexa can use either of the, like if there are total k colors, k different colors, so she can use at one of the different colors to color it, right? And the cost associated with coloring each wall with a particular color is told with the help of a array, right? It has been told in an array. So suppose that there is an ith wall, right? So suppose like there is an ith wall. So in that case, if there is an ith wall, so in that case, if there is ith wall, right, if you want to paint the ith wall, so let's suppose that the k value was 3. So if there are 3 different colors, right, if it was the ith wall, right, if I talk about the ith wall, right, if I talk about the ith wall and the k was 3, so in that case what will happen, you will have a cost vector. So cost of, let's say the ith wall was there, so cost of i0 will there will be a cost of i0, there will be a cost of i1, right, and there will be a cost of i2, right? So basically there will be 3 different costs, right? There will be 3 different costs, right? That is what the problem says. If k value is 3, suppose if k value is 3, right, if k value is more, like k value can go to 1000, right? So they can be 1000 different colors. You can see k value can go till like 1000, so that they can be 1000 different colors, right? And they can be 1000 walls as well. So now in this part what they are saying is, they are saying that what you have to do is, you need to minimize the cost. You need to find what, sir, can you write in Python, like Chandra Datta Patel? I cannot write in Python, I am not so proficient in Python, but I can tell you a very simple and very efficient code in C++ that you can definitely translate. I'll tell you the complete thought process. I currently cannot make you I cannot make you available with the Python code. I can write a clean code in C++, and from that you can take inspiration and you can write in Python. The logic will remain very, very simple, believe me. Okay, now in this part what it's saying is, you for example, if the cost for the 0th wall, right, because we are following a zero based indexing, the cost is 0 0, right? So in that case, like there will be colors, right? So you have to find the minimum cost, and you need to make sure that what you need to find the minimum cost to paint all the walls such that no two walls are of the same color, right? No two adjacent walls, right? It is saying that you need to find the minimum cost, right? So you need to minimize the cost, right? So if I ask you to minimize the cost, right, so suppose there were a lot of walls, right? Suppose there were 2 walls, right? Suppose there were 2 walls, then you would have said that we would try to minimize the cost by choosing the minimum color, like minimum like suppose that there were 2 walls, right? Suppose there were 2 walls, suppose there were 2 walls, and for the first wall, suppose that there were colors, there was a color of, there was, suppose k was 3, and there was a color of 0 type, 1 type, 2 type, right? If this was the case, right, so in that case what you could have done is, if this was the case, so if the, let's say for the first wall the cost was coming out to be 50, this cost was 60, this cost was 70. Suppose for the second wall the cost was coming out to be, let's say 50 again, let's say not 50, but let's say it was coming out to be, let's say 60, this was coming out to be 80, this was coming out to be 70, right? So in that case you will say that, okay, for the ith wall, for the first wall, the minimum cost will be 50, and then you will say that for the second wall the minimum cost will be 60. But that is not true, because what the question is saying, if you read the problem statement, it is saying that no, you need to find the minimum cost to paint the walls such that no two adjacent walls have the same color, right? So if you are using the 0th color, if you are using this color, if you are using this particular color in the first wall, then for the adjacent wall you will not use that color, right? So you'll use either 80 or you'll either use 70, right? So maybe if you use 70, if you use this color, then the cost will be 50 plus 70, that is equal to 120, right? Or maybe other than this, what you could have done is, let's say what you could have done is, maybe if you choose this color 64 here, and you choose like this color, like this color 1, this color of type 1 here, and this color of type 0 for this, then 60 plus 60 could give you 120 as well, right? So they can be various ways, but you need to minimize the cost. Is it clear to everyone? Is the question clear to everybody? Everyone is clear with the question, guys? Everyone is clear with the question? Everyone is clear with the question? All of you are clear with the question or not, guys? Everyone is clear with the question? You can write a clear in the chat, guys, if you're clear with the question, right? That's what you have to do. You have to find the minimum cost such that no two adjacent walls are having the same color, right? That is what you have to do in this problem. Is it clear to everyone? That is what you have to do. You can write a clear in the chat, guys. Okay. Perfect. perfect. So that is what you have to do. Now let's try and see like what I will be doing here. So I can say that like you need to think of some cases. So suppose what happens is everyone can write a clear or a +1 in the chat, guys. All of you can write a clear or a +1 in the chat. Now what will you do, right? What will you do? So first of all, you need to find that how many number of walls are there, right? So can I say that the number of walls that are there is nothing but costs dot size, right? Basically the number of walls, you need to find the number of walls, right? Suppose that the number of walls is 0, right? Suppose that the number of walls is 0. If the number of walls is equal to 0, right? So this means that number of walls is 0 if there are no walls, right? So basically that means that no walls are there. If no walls are there, so can I say that I can simply return a 0 because there will be no cost, right? There will be no cost, right? Because the cost will be 0, right? The minimum cost will be 0. And I can say that I need to find the number of walls as well, right? I can say that k is the number of colors, right? K is the number of colors. So if I want to find the colors, so that's nothing but costs of 0 dot size, right? Basically I need to find the number of columns that will tell me the number of different colors, right? For a particular wall, if I find the number of different colors, so that will tell me the total number of colors that are there. And now you need to see, right? Now you need to see that what happens is, if it happens that if the number of colors is 0, right? If the number of colors is 0 also, then also you can say that you will return a 0, right? If there is no color, in that case the cost will be 0, right? Okay, that's pretty much basic. Now what I can say is that you need to think in a simple manner. So can I say that suppose that what if the n value is just 1? Suppose that n value is just 1. So if the n value is just 1, right? So if there is just one wall, so you will try to print it with the minimum, right? You will try to print it with the minimum. But what I'm saying is, you always keep a track of two things, right? You always keep a track of two things. Now can I say that what will you do, right? What will you do? Like let's say there are a lot of walls, right? Let's say there is wall, like there is wall 1, then 2, then 3, like then 4, then up till n, right? There are n walls. So can I say that one of the things that I can try to do is maybe I can have, suppose that I can print it with minimum, like I can paint it with minimum 1, so is that the colors are not the same, right? I'll try to print it maybe with minimum 1, and then maybe with minimum 2, this kind of stuff, then maybe minimum 1, this kind of approach I can think of, right? So basically first of all, I'll store the minimum 1, the least cost. I'll first of all have the minimum cost. I'll have two variables. I'll be using two variables to implement this DP in a smarter fashion. So what I'll say is that this will help me to find the minimum cost. This will help me to find the minimum cost, and this will help me to find the second minimum cost, right? After the minimum cost, what is the second minimum cost, right? So these two variables I'll be using smartly to implement this DP concept, right? Because like what I'll be doing is, I'll tell you here. So what I'll do is I'll have these things, right? So I'll say that int if I want to find minimum 1, so if I want to find something minimum, so I initialize it as int max. Similarly here also, if I want to find something, so int min2 is equal to nothing but int underscore max, right? So I'll initialize this like this, and then what I will be doing is, so basically this will store the first minimum value, right? Min1 will store the first minimum value, right? Min1 stores the min1 will what stores the first minimum value, right? First minimum value, right? First minimum cost, you can say, was first minimum value kind of thing, you can say. And like min2 will do what? Min2 will store the second minimum cost. Okay, is it clear to everyone? Second minimum value, right? Second minimum value, right? Okay, right, that is what will happen. Reason for doing with DP instead of greedy, because you cannot do it with greedy, right? The Ritik Kumar, you cannot do it with greedy, because such kind of questions, like how will you do it using greedy? If you will do it using greedy, then you will fail somehow or the other, because you will not be able to find the most optimal way for you, right? Suppose that what you do is, like what will you do in greedy, right? Suppose that I tell you an example. So let's say you have one wall, two wall, three walls, and you have the color of first kind, second kind, and third kind, right? And let's say I'm writing the cost for everything. So let's say you take 60 here, 50, and then 40, let's say, and let's say you have here as, like let's say 50, 70, and 80, right? And let's say here what you have is, you have 30, you have 20, and 10, right? So what you will think of doing is, maybe what you will, let's say what you do is, let's say this is 50 here, and this is 40 here, and this is, let's say, 60 here, right? So in this case, like if you will try to think, so what you will say is that maybe I choose this color here, right? If I choose this color here, then the adjacent colors cannot be same. This is nothing but the colors, right? This is nothing but the colors, and this is nothing but the walls, right? So why greedy will fail? Because if you choose this, then what, like suppose you will not choose this 50, right? Basically you will choose this color, right? If you're trying to be greedy, so you can write agree in the chat, Ritik, you will choose this 40, right? If you choose this 40, then what is the minimum, right? Can I say that you will choose this 20? But instead it might have been the case that you might miss this, right? You could have chosen 10 as well, right? So you might have been a little bit more smarter in your choices. And like if you will consider a long answer, if you will consider a long like if you will consider a test case where the number of walls will be a lot and the number of colors will be a lot, so in that case you might end up skipping a lot of walls that are having providing you the lesser colors, right? In that case, suppose that in case of this I have, let's suppose that only I have 20, right? In case like down here I have just 20 here, so I can say that I'm missing this 20 and I'm missing this 10 both, right? I'm missing this 20 as well as this 10, right? So in that, because can you, if you have chosen this color, if this color, second color you have chosen, so you cannot choose this color, right? Agree in the chat, right? Please write agree in the chat. Ritik Kumar, you're clear with this part? If you will try to be greedy, so for every level you will try to choose the minimum, right? So suppose that you choose this, if you choose this, right? So basically suppose that this is 70, right? Suppose this is 70, so in that case if you choose this thing, right? Suppose that you choose this thing, so in that case the next step you choose this, and then maybe you choose this, but you are missing two of the things, right? You are missing this 20, you are missing this 20 and 10, which are much lesser values, right? So if you are choosing it like this, so let's find the sum. So if you are choosing it in a greedy manner, so maybe what I can think is you are choosing 50, then you are choosing 40, and then you are choosing 10, then you're choosing 20. Okay, so the overall sums comes out to be what? The sum I think comes out to be nothing but what? The sum comes out to be, I think 110, right? But if you think like what you could have chosen it like was, you could have chosen maybe like this. If you chose it like this, maybe then this, and let's say then this, so it would have been what? 60 plus 20 plus 10. So in that case it would be what? It would be nothing but what? It would be nothing but this thing. It would be nothing but this value is 90, right? So the cost is lesser, right? So clear with this part, right? In that is why you need to apply a DP concept, because in the greedy fashion you will try to choose the minimum at every level, but you don't know the future, right? You don't know that maybe you could have chosen this guy, right? So that's why, right? So you'll have the int min and int min 1 and the min 2, right? These things you will have, and then what you will have is you'll have a DP, right? You will declare a DP. So let's say you declare a DP of n size, so you will declare a 2D DP here. So vector of vector int, right? And then DP, is it clear to everyone? Is it clear to everyone, right? DP, and I'll declare like DP of n cross k size, right? That is what you will be declaring. So this DP I'll declare, right? Once I've declared let's say this DP, right? So I'll declare this DP. Okay, so to store the answers, right? Is it clear to everyone? Is it clear to everyone else? Okay, now what will you do further, right? What will you do further? So what will you do? You will say that suppose that I'm like, do you know in DP we need to initialize the values, right? So suppose like in this case, suppose that I haven't chosen any wall, right? So can I say that I need to, like, for DP of I0 I want to have some things, right? Basically for the base level, for the level when I am not considered it, I want to initialize, right? I want to initialize my DP of I0 to cost of like this thing, right? Cost of 0 I, this thing, right? I need to iterate through all the colors and I need to do this thing, right? I need to do the initialization part, right? And I also need to find the minimum 1 color and the minimum 2 color. Okay, the first minimum color and the second minimum color, right? Cost of the first minimum color and the second minimum color. So what I will say is that I'll say that for int I starts from 0, I is lesser than what? I starts from 0, I will be lesser than nothing but k, right? I will be lesser than k and I plus plus, right? And then like what I'll do here is I plus plus, right? And then what I'll do is I'll say that DP of 0 I, that is for the first case, for the very first wall. I'll say that the cost will be this, right? I'm initializing the cost initially, right? I'll definitely choose, I'll tell you what will happen, but this is how I'll be doing the initialization, right? This is nothing but the initialization, right? Initialize the DP, right? I'm initializing the DP. Is it clear? Is it clear up till now, guys? Everyone is clear up till now? Yes or no? Are you all clear up till now? Okay, right. Now next up what you will do is Next up, once you have initialized it, right? So what are you going to do, right? You have initialized the DP. I said that you will find the minimum 1 and the minimum 2. So you will say that if the cost of, for the, you are considering for the 0th wall only, right? For the very first wall you are considering. So if the, you have iterated, so if the cost of 0I is going to be lesser than the minimum 1, right? If the minimum 1 is store the least minimum, right? If it is lesser than the minimum 1, in that case what I'll say is that minimum 1 will get updated to the cost of 0, right? So if there is a cost that is lesser than the minimum, right, that is the lesser than the first minimum, right? So in that case I need to update my minimum 1. So whatever was the minimum, like in that case what will happen, whatever was the minimum 2 cost, second minimum cost will be now the minimum 1 cost, right? The like whatever was the second minimum cost, that needs to get updated to the minimum cost, because I've found a new minimum cost, right? So I'll say that minimum 1 is equal to nothing but costs of what, I'll use a cost here, right? I'll use a cost here. So cost of nothing but 0 and I, right? That is what I will do. Is it clear, guys? That is what I will do, right? And then after I've updated this part, so I'll say that else if it happens that suppose that the least minimum, like minimum 1 is storing the least minimum, right? Minimum cost. So if suppose that if the current cost for the current wall, the very first wall, for the current, if cost of I is not lesser than minimum 1, but it is lesser than the minimum 2, right? If it is lesser than the minimum 2, if it is capable of becoming the second minimum cost, so I'll update the second minimum cost only, right? So I'll say that second minimum cost is equal to this thing, right? That is what I will do, right? Is it clear to everyone? Is it clear, guys? Is it clear? You can write a clear in the chat, right? Okay, now what I'll do is, suppose that if there is just one wall, right? If there is just one wall, if n value was 1, so I'll just move down a little bit. So if n value was 1, right? Suppose that if the n value was 1, then I'll return what? I'll return the minimum 1 cost, the least cost, right? Yes or no? I'll return the least cost that I have to incur, right? Right, I should return the least cost or not? Yes, I should return the least cost. Otherwise what I'll have is, otherwise can I say that for the next levels, I, like, why am I using the minimum 1 and minimum 2? Because I might be wanting to use them alternatively, right? Kind of this thing, I might want to use them alternatively, so that every time I'm either using the minimum cost or the second minimum cost, second minimum cost. Agree? Clear with this part? Why am I trying to do this? I'll try to use the minimum cost, then the second minimum cost, second minimum cost of different colors. Maybe I'm trying to think in this fashion. Okay, right? That is what I'm trying to think. Now what I'll say is, I need to, if I'm now suppose that it was case when if it was 1. So but if it is not the case, if there are several colors, right? If suppose that there are several walls, so in that case I need to iterate through all the walls, right? So I'll say that in that case I need to have the current minimum, like I need to have the current minimum 1, right? I'll if I'm having more walls, in that case I need to have current minimum 1 and current minimum 2. Okay, because if I'm iterating from more than one wall, so I'll require these variables to always keep on updating my minimum 1, right? So minimum 1, I'll try to update, like current minimum 1 and current minimum 2 will tell me that what will happen in this. I'll try to, current minimum 1 and current minimum 2 will help me to always keep a track of the current minimums. Okay, and then according to them I'll update my minimum 1 and minimum 2. Okay, because I'm iterating through all the walls and the colors, right? So all the walls and colors, if I'm iterating for the ith wall and the for the ith wall, I'm iterating through all the k colors for it. So what I'll try to do, I'll try to find the current minimum for that wall, for the ith wall, and the current minimum 2 for the ith wall, right? The minimum cost for that wall and the minimum cost 2 for that ith wall. And if it is lesser, if it is optimal to change the original minimum 1 and minimum 2, then I'll change it, right? Okay, is it clear to everyone? Is it clear to everyone? That is what I'm trying to think. Okay, that is the way that I'm trying to think alternatively. So what I'll say is that I'm done for this. So int I starts from 1, right? And I is lesser than the number of walls and I plus plus, right? And similarly what I'll say is, for, let's say what, int j starts from 0, j is going to be lesser than k, and then I'll do a j plus plus, right? Once I'm done with this part, so what I will say is, I'll check for my previous, right? I'll check for my previous, right? I'll check for my previous, right? I'll check for my previous thing, and what I'll say is, I'll check for my previous. So if I have to check, if I'm at the the previous wall was what? The previous wall was I is equal to 0. The current wall is I is equal to 1, right? The current wall is I is equal to 1. According to a 0 based indexing, the current wall is I is equal to 1. So what I can say is that if the previous, right, if it happens that dp of this thing, dp of I minus 1, right? Previous wall, for the previous wall, for the same for the previous wall, the jth color, if it is not equal to minimum 1, right, if it is not equal to minimum 1, right, if it's value, if it is not equal to minimum 1, right, if it's not equal to minimum 1, right, so I can say that for the current wall dp of ij, for the current wall, if it's not equal to minimum 1, so that for the current wall I can add this cost, right, so I can say that in that case I'll say that cost of what, I can say that cost of ij, I can add the current cost for the wall, and I can say that I can add minimum 1, right, up till now whatever I've calculated, right. Okay, so that is how I can update it for the previous wall, right. If the previous wall is not having the same minimum 1, right, if the previous wall is not having the same cost as minimum 1, right, so in that case I'll update it. Else if it is having the same, then I'll update it with minimum 2, right, so I'll say that dp of I and j, right, that is how you do it, right. Dp of ij is equal to cost of what, I and j, right, plus minimum 2, okay, plus the second minimum cost, right. If it is not if it is same, right, I'm saying that what you're trying to do is you are trying to update, right, you are trying to update, so either you will update it with minimum 1 or minimum 2. So if it is already, if the previous wall is occupied with the minimum 1, so right, if the previous wall is occupied with this thing, so you will, in the next time you will you will update it with minimum 2 or minimum 1, you will use them alternatively so that you can minimize your cost, right. Okay, that is why you are doing it, you are trying to minimize your cost. Okay, that is what your objective is. Now what you will say is that once you have processed this thing, right, once you have processed this part, so what you will say is you need to find the current minimum 1 and the current minimum 2, right, so that you can update the final answer. So you'll say that if it happens that dp of I j, right, dp of ij is lesser than current minimum 1, right, if it is lesser than the current minimum 1, then what will you do? If it is lesser than the current minimum 1, so current minimum 2, right, current minimum 2 will get updated to current minimum 1, right, current minimum 2 will get updated to current minimum 1, and current minimum 1 will get updated to nothing but dp of I and j, right. Is it clear to everyone? Right, that is what will happen. Else if it happens that the current if it happens that dp of ij, right, I'm trying to find the current, right, for the ith I comma jth dp, I'm trying to find that, okay, what is the current minimum cost, right. Okay, so I'll say that if this is lesser, right, so if only the minimum 2 is getting updated, so I'll update it with dp of I and j, right, so that is what I will be doing. Now once I'm done with this part, right, so once suppose that I'm done with this part, so once I'm done with this part, so what I'll do here, can I say that I'll update the overall minimum, right, I'll update the overall minimum. So I'll say that the minimum 1, I'll update the minimum 1, I'll update the minimum 1 as what, minimum 1 is equal to current minimum 1, right, I'll update the minimum 1 as current minimum 1, minimum 2 is updated as what, minimum 1 will be updated as current minimum 2, right, whatever is the current minimum I'll need to update, right, I need to update it with this part. And then I'll say that what current, I'll update, I'll say that current minimum 1 will now again the current minimum will tell me for each iteration, right, for each iteration current minimum 1 will get updated, right. So that is why, like, this will be done after this color loop is over, right. Okay, so current current minimum 1, I'll say that, okay, I need to update it once again, right, I need to say that current minimum 1 will find the minimum 1 and minimum 2 once again in the next iteration, so that's why I need to initialize it as int max once again, right. And then I can say that suppose if my cost is lesser than 0, right, so I can say that my minimum 1 is storing the current answer, right, my minimum 1 is storing the minimum answer. So if it happens that minimum 1 is gonna be lesser than 0, right, if the minimum 1 is gonna be lesser than 0, what if the minimum 1 is lesser than 0? Suppose this part, suppose that after some calculations, if the minimum 1 is still negative, if it is still negative, right, so can I say that the answer is not possible, right, if the minimum 1 is lesser than 0, is it indicates that the answer is not possible, right, if the minimum 1 is, if after several iterations, right, if the minimum is still lesser than 0, in that case you will return what, you will return -1, because you will say that the answer is not possible, right, right, you will say this part, right, you will say that the answer is not possible, guys, yes or no, tell me quickly, you will say that the answer is not possible. Otherwise if the minimum 1 is not negative, in that case you will say that minimum 1 is showing the minimum answer and you will return minimum 1. Let us try and compile this to see if there is any error in this part. Okay, so it is saying that dp of what costs was not declared. Okay, I should use this word as costs, right. Now let's try and compile this. Okay, is it clear, guys? So it seems to work on the samples. I think we are getting the output as 8 for the sample test case, I think, right. So let us try and submit this to see if this approach works or not. I think it should get accepted. Okay, so it was able to pass all the test cases. So is this approach clear to everyone? Is this DP approach clear to everyone? Every time what you are doing is, you are not going, this condition is most important, right? in this part, this condition is most important, that if the previous, if for the same, if the previous color is not allocated, right, if the dp of I minus 1 j is not equal to the minimum one, right, which is storing the current minimum, if it is not the same, in that case you can afford to choose the minimum one, otherwise you will choose the minimum two, right. So you will try to alternatively choose the minimum one and the minimum two, so that you can try to minimize your cost. Okay, is it clear to everyone? Clear with this part, guys? Everyone is clear with this part, that you will try, like what will you try to do every time? The minimum one and minimum two are trying to get the optimal costs for you, right? The minimum cost and the second most minimum cost, right? The minimum most cost and the second most minimum cost. And then what you are trying to do is, if you're trying to find the minimum and the second minimum cost, every time you are keeping a track of the minimum and the second minimum cost. So if you have previously used the minimum cost, then what you will do, if you have previously used the minimum cost, minimum cost, then you will try to use the second minimum cost. Otherwise, if you have tried to use the, if you have used the second minimum cost, then you will try to use the minimum cost now, right? So that is how alternatively you will try to reduce the cost, and ultimately your cost will be minimum, right? Okay, using the dp thing. Is it clear to everyone? Clear with this part? You can write yes in the chat, guys. So that's how you have to solve this problem. You can take a screenshot of this if you want. You can take a screenshot of this, right? So basically, first of all, what you do is, right, base cases, you have to cover base cases, right? If it happens that n is equal to cost dot size, is it clear to everyone, guys? Is it clear? Okay, I think it's clear to Summer. What about others? So if it happens that there are no walls, in that case you simply return a zero. If the k value is equal to zero, right? If the k value is equal to zero, in that case, like there are no colors, so you'll return zero, right? There is no cost. Otherwise, you will try to find the minimum cost and the second minimum cost, right? You'll try to find the first minimum cost in min one and second minimum cost in min two, right? You'll initially initialize them as int max for both minimum one and minimum two, and then you'll iterate thinking that, suppose that there is just one wall, right? So in that case, what you will do is, like, first of all, you initialize the dp, right? So you'll say that dp of I0 is equal to cost of 0 I minus 1, right? 0 I. Basically, you are trying to do this, right? Because, like, first of all, you should have some initialization in the dp, right? So for the very first wall you are doing this. Then what you're keeping a track of is your, if you see for this, right, if you see, so minimum one is keeping a track of the minimum cost, right? And minimum two is keeping a track of the second minimum cost. So what you're trying to see is, for the first wall which is indicated by I is equal to 0, for the very first wall which is indicated by the value, I is equal to 0, what you're doing is, you're trying to find the minimum 2 is equal to minimum 1, right? You are trying to find that what is the second minimum for the very first wall, what is the minimum cost and the second most minimum cost, right? So you are trying to update it. If the current cost for a particular color, for the very first wall, if the current for any particular color, if the cost is lesser than the most minimum cost, in that case I'll update the second minimum cost to the minimum cost, because it will get updated, and the minimum cost will get updated to cost of 0 I, right? And otherwise, else if it happens that the cost, if the current cost is lesser than the minimum 2 only, right? If it is not lesser than the minimum 1, but it is lesser than the minimum 2 only, if it is lesser than the second most minimum cost, then I'll update my second most minimum cost, right? And what you need to say is, if suppose that there is just one wall, if there's just one wall, then you will agree to me on this part, that you will spend what, you will spend the minimum cost on it, right? You will spend the minimum cost on it. Otherwise, every time you need to calculate, right, every time you need to calculate the minimum cost and the second most minimum cost, right? Every time what you need to do is, you need to calculate the minimum cost and the second most minimum cost, starting from the second wall, that is from I is equal to 1, right? Because we are following a zero based indexing. So from I is equal to 1, that is the second wall, for all the key colors you will iterate and you will try to find this, right? So you'll say that if the previous wall, if for the previous wall with the same color, if for the previous wall with the same color, the cost was not equal to minimum 1, right? If you have not used minimum 1 there, if for the previous right, if for the previous you have not used this particular thing, in that case you can afford to use the minimum cost for this color, right? Otherwise, if you have used the minimum 1, then you will use the minimum 2, so that the adjacent walls do not have the same color, right? And then what you can say is, you need to find the current minimum one, right? Because in the dp of ij, the current minimum, if the current minimum you are trying to find every time for the ith and jth. So if it happens that the current minimum one, right, because every time you need to find the minimum, so that's why you are using the current minimum. So if the current minimum 2, if the current minimum if the current minimum cost is greater than the current I comma jth cost, in that case you will update it, right? And if it is happening that current minimum like second most current minimum cost is greater than the current cost, right? So in that case you'll update it, right? And then what you'll say is you are ultimately updating it to what, right? Once you have updated it for the current wall all the colors, for the current ith wall you have updated it for all the colors, right? So you are doing this, you are updating the minimum, current minimum and current minimum, like current this thing, like the Java solution will exactly be the same, Bunny. The Java solution will exactly be the same. You can just take a screenshot of this part. The Java solution still remains the same because we are just using arrays, 2D arrays and things like that, right? There is nothing much STL used or any particular C++ thing is used, so Java solution still remains the same. It's just that you have to use math.max and math.min kind of thing, right? Otherwise everything remains the same. So else if it happens that dp of ij, right, if it is the current minimum, right, for this the current minimum current second most minimum is getting updated, so you'll update it. And then every time what you are doing is every time for the ith wall, if you have processed for all the colors, for the ith wall after processing all the colors, right? Okay, you are saying for that part, you are saying for rabbit for that solution, yes, count of a comma count of p plus 1, yes. So you will update your minimum 1 and the minimum 2 with the current cost, and then you will say that current minimum 1 and current minimum 2 needs to point to positive infinity, right? Because every time for every wall, for every new ith wall, you are trying to find for all the k colors that what is the minimum cost, right? And then you are updating this, right? So that every time you are most optimal. And if it happens that in the end, if the minimum cost is coming out to be lesser than 0, that means that the answer is not possible and you'll return -1, right? Because it says that if it is not possible, you have to return -1, otherwise you have to return the minimum cost, right? And that is stored in the minimum, right? So that's what we have to do, right? And talking about this problem, right, this problem talking about minimum steps required, so I'll quickly walk you through this. So basically in this you were given consecutive segments of A's and B's, and what you had to do was you had to find the minimum cost, you had to find the minimum number of steps, right? So in that case what you did was you counted the number of consecutive segments of ones, and they counted the in count underscore A, you counted the consecutive segments of A's, and in count underscore B what you did was you counted the consecutive segments of B's, right? And then what you did was you will choose the minimum segment, right? As I mentioned earlier as well, right? Let's suppose that this case was there. Just walking you through, if someone has joined just now, so suppose A, this kind of a case was there, right? Just walking you through it again. If A was there, B was there, A, and then B, right? And then A was there, right? So what you will do, the consecutive, like you will say that count underscore is A is what? There are 3 segments of A, right? This segment, and this segment, and there are 2 segments of B, right? The segments of B is nothing but 2, so you will take the minimum segments, right? Because if you remove this segment of B and this segment of B, then the cost comes out to be 2, right? And then all the A's are together, right, plus 1, so the cost will be 3, right? So otherwise if you do this way, that first of all you remove all the A's, then the cost will be 3, because you're removing 3 different consecutive segments of A, then all the B's come together, so you remove it, so the cost will be 4. So that's why you'll remove minimum of the consecutive segments of A and B, and then you will return minimum of consecutive segments of A and B plus 1, right? That's what you will do here. And similarly for this problem, that is maximum level sum in a binary tree. So in this problem, as I mentioned, for every level you will try to find the sum. You have to do what? You have to find the maximum, right? Here you have to find what you have here in this problem. What you have to do is you will be given a binary tree, and what you have to do is you have to find the minimum. You have to find what? You have to find the basically the maximum sum for a particular level. You have to find the maximum sum at a particular level, right? So what you will do is you will try to find the sum at each and every level, and then every time you will do what? You will update your maximum, right? You will update your maximum with the sum, right? If the current level sum is greater than the maximum that I have stored up till now, so that is what you will be doing, right? So these were the 3 problems that we discussed. One problem I think was greedy, another problem was based on trees, and one problem was hard DP problem, right? So these 3 problems were there. All of you can write yes in the chat, +1 in the chat, so that we can end this stream now. We have discussed all the 3 problems, so that is it for today. Make sure to solve all these problems after this live stream is over, right? Thanks a lot everyone for being patient and following the live stream, and I'll see you in another live session or maybe in the problem of the days. Thank you for watching.